Okay, good day everyone. I am Maria Riamson. So today we talk about the stem cells therapy. So here's the objective. At the end of the lessons, you should be able to explain the stem cells therapy and its various forms and assess the potential benefits and determinants of stem cells therapy to medicines and healthcare. So now let's start. The conceptualizations of stem cells therapy began in the 1960s. However, early-age attempts at transferring cells were unsuccessful following its timeline of the development of a gene therapy. We have here in the 1960s, research began on the stem cells taken from an adult tissue. So this early research aimed to understand the fundamental properties of stem cells, such as their ability to differentiate into various cell types and their role in tissues developing and repair. So in the 1960s, the research began, or the stem cells therapy began. Next, in the 1968, adult stem cells were used to treat an immunodeficiency. When we say immunodeficiency, it is an immune deficiency disease or a disorder occurs when the immune system is not working as expected. So this year is a groundbreaking medical procedure was performed where adult stem cells were used to treat a patient with an immunodeficiency disorder. This marked one of the first clinical applications of stem cells therapy, demonstrating its potential to address severe medical conditions. In the year 1998, in the U.S., scientists grow in stem cells from human embryos and germ cells, establishing cells lines still in use today. So in 1998, this research in the United States, they established a stable cells lines, which is a populations of cells that can be maintained and grow over a long periods. In year 2001, an embryonic stem cell stored into a blood cell. So in the year 2001, they discovered that the embryonic stem cells turn into blood cells. This achievement showcased the versatility of embryonic stem cells and their potential for generating specific cell types needs for healing purposes. When the year 2024, in the South Korean, scientists cloned 30 human embryos and developed them over several days. So the South Korean scientists, they highlighted the potential of cloning technology in stem cells research, raising possibilities of generating patient-specific cells for therapies. In the year 2005, in the same team in the South Korea, scientists developed a stem cells tailored to match individual patients. So this in the year 2005, this breakthrough suggested the potential for personalized medicines, where stem cells could be used to generate tissues and organs compatible with the patient's immune systems, reducing the risk of rejections. In 2006, the Japanese scientists in Japan, they identified conditions that would allow some specialized adult cells to be reprogrammed genetically to assume a stem cell-like state. And this reprogrammed cells known as indels on a pluripotent stem cells. They have the ability to differentiate into a various cells types similar to embryonic stem cells. They offering a new avenue for developing a medicines without using embryos. In the 2012, in the U.S., scientists extracted stem cells from a clone monkey embryos and they developed them into a mature heart and nerve cells in the laboratory. So, in 2007, in American scientists, this is an achievement demonstrated the feasibility of using clone embryonic stem cells to generate a specific cells type of research and potential healing applications, advancing the field of developing medicines. That's the year where the stem cells therapy began. These pictures, these are the human stem cells applications. This is specialized cells in the human body have a unique structures and functions that allow them to perform a specific task. Erythrocytes or the red blood cells, they are specialized to carry oxygen through the body. They contain the red blood cells, which is increase their surface area for a gas exchanges. And we have here the neurons or the nerve cells. They going to transmit electrical signals through the nervous systems. They have a long projections called axons that allow them to send message over a long distance. A human disease that can be treated by the stem cells therapy. First, we have here the diabetes. Stem cells can be used to make new insulin-producing cells to help people with diabetes control their blood sugar. That's in the diabetes, the stem cells, they can make a new insulin-producing cells to help people who have diabetes. Next, we have here rheumatoid arthritis. The stems can help fix and grow joint tissues, reduce inflammation and ease symptoms for people with rheumatoid arthritis. They can cause severe damage to the joints and their surrounding tissues. It can lead to heart, lung, or the nerve system's problem. And the common symptoms, they include stiffness, tenderness, and heat. It can make hard to move and perform daily activities. Next, we have here a neurodegenerative disease or a Parkinson's, Alzheimer's. And the stem cells, they can replace lost or damaged brain cells and improve brain function in this disease like the Alzheimer's. In the osteoarthritis, stem cells can regrow cartilage in joints, which can help reduce pain and improve movement in people with osteoarthritis. So, next we have here the stroke and traumatic brain injury. The stem cells, they can help repair brain damage caused by a stroke or injury. It is a potential improving a recovery and a brain function. Next, we have here the spinal cord injury. In the stem cells, they can help the spinal cord injury may restore a movement and feeling in people who have these spinal cord injuries. When it comes in the heart disease, the stem cells can help repair the damaged heart tissues, helping the heart to work better after a heart attack or in a heart failure. And a cancer, the stem cells can help regrow a healthy blood cells after a cancer treatments and might be used to create a target treatments that kill cancer cells. And a baldness, when the stem cells can help also to regrow a hair by stimulating the hair follicles. And a hearing problems, stem cells can help fix the tiny cells in the ear that are needed for hearing, potential restoring hearing. Okay, when it comes in a Crohn's disease, stem cells can help also to reduce a gut inflammations, and they also repair the damaged tissues in people with a Crohn's disease, improving the symptoms, to improve the symptoms. When it comes in also in the wound healing, the stem cells can speed up healing by helping skin and other tissues regrow, reducing and help other tissues to grow. And a male infertility, stem cells can help produce new sperm cells and fix damaged reproductive tissues, potentially helping with a male infertility. So these treatments are at different stages of research and use. They use with some already helping the patients, and others will still be studying. And others still being studied. So now, the stem cells. The stem cells are basic cells that are able to develop into any type of cells in the body. So they have the capacity to create more stem cells and to differentiate into a different cells types. So the human body uses the stem cells to replace worn out cells. Specialized cells in a human body have a unique structures and functions that allow them to perform a specific task.
There are 3 types of stem cell. First is adult stem cells. It produces only a limited number of human cell types. They replace existing cells in the organ as they wear out and die. One of the key characteristics of adult stem cells is their multipotency, meaning they can differentiate into a limited range of cell types specific to the tissue or organ in which they reside. Adult stem cells are involved in the body's natural healing processes, such as repairing damaged tissues and maintaining homeostasis. They can be activated in response to injury or disease to regenerate and replace damaged cells. One example of adult stem cells in action is the use of hematopoietic stem cells in bone marrow transplants. Hematopoietic stem cells are a type of adult stem cell found in the bone marrow that gives rise to all blood cell types, including the red blood cells, white blood cells, and platelets. In bone marrow transplants, hematopoietic stem cells are collected from a compatible donor, such as a sibling or unrelated donor, and transplanted into a patient with a blood disorder or cancer such as leukemia. The transplanted stem cells migrate to the bone marrow and begin to produce healthy blood cells, replacing the diseased or damaged cells. Second, embryonic stem cells. These are created from leftover embryos that are willingly donated by patients from fertility clinics. One of the defining characteristics of embryonic stem cells is their pluripotency, which means they can give rise to all 3 germ layers of the body: ectoderm, mesoderm, and endoderm. This broad differentiation potential allows embryonic stem cells to generate a wide range of specialized cell types, including neurons, muscle cells, blood cells, and more. These embryos are donated for research purposes with informed consent, and the inner cell mass is isolated to establish embryonic stem cell lines. These cell lines can be maintained in culture indefinitely and have the capacity to proliferate rapidly while retaining their pluripotent properties. Last is induced pluripotent cells. These are regular skin, fat, liver, nerve, or other cells that scientists have modified to behave like embryonic stem cells. The discovery of iPSC by Shinya Yamanaka and his research team in 2006 revolutionized the field of regenerative medicine by providing a way to generate pluripotent stem cells without the use of embryos. iPSC offers several advantages over embryonic stem cells, including their patient-specific nature, which reduces the risk of immune rejection in cell-based therapies, and the avoidance of ethical concerns associated with the use of embryonic tissue. iPSC exhibit characteristics similar to embryonic stem cells, such as pluripotency and the ability to differentiate into various cell types, making them a valuable tool for disease modeling, drug discovery, and personalized medicine. Personalized medicine, in which human organs can be grown in the laboratory to replace damaged organs and, in theory, replace older cells to delay the aging process. In personalized stem cell therapy, patient-specific stem cells can be differentiated into the cell types relevant to the patient's condition, such as neurons for neurological disorders, cardiomyocytes for heart diseases, or pancreatic beta cells for diabetes. These specialized cells can then be used for disease modeling, drug screening, and regenerative medicine applications aimed at repairing or replacing damaged tissues. Personalized medicine and stem cell therapy refers to the use of a patient's own cells, such as induced pluripotent stem cells or adult stem cells, to develop tailored treatments that are specific to an individual's genetic makeup, disease profile, and medical history. This approach aims to deliver targeted and precise therapies that take into account the unique characteristics of each patient, ultimately improving treatment outcomes and reducing the risk of adverse reactions. Bone marrow transplant. It is a method of stem cell therapy that has been used for many years without controversy. This process involves harvesting stem cells from the patient's bone marrow, typically from the pelvis, using a large needle that reaches the core of the bone. This procedure aims to replace damaged or diseased bone marrow with healthy stem cells to restore normal blood cell production and immune function. A matched donor is a requirement for bone marrow transplants, so finding a matched donor is crucial. The best match is often a sibling, but if a sibling is not available, then unrelated donors or umbilical cord blood can be used as alternative sources of stem cells. Then we have the somatic cell nuclear transfer. It is another method that consists of taking an enucleated female ovum and implanting a donor nucleus from a somatic cell. The ovum is then stimulated to divide as if it is being fertilized, thus creating a human embryo. Somatic cell nuclear transfer, in simple terms, it is a scientific technique where the nucleus containing genetic material of a somatic cell, any cell in the body except sperm and egg cells, is transferred into an egg cell that has had its nucleus removed. This process creates a new cell that has the genetic material from the somatic cell. The resulting cell has the potential to develop into an embryo and, under certain conditions, can be used for research purposes or to create cloned animals. Countries like Germany, Austria, Ireland, Italy, Norway, and Poland prohibit the use of human embryos for stem cell research due to ethical, moral, and religious concerns regarding the destruction of human embryos. These countries have laws and regulations reflecting societal values and religious beliefs that prioritize the protection of human embryos. Alternative stem cell sources, such as induced pluripotent stem cells and adult stem cells, are favored to avoid ethical controversies. Public opinion and the desire to respect the sanctity of human life contribute to the restrictions on using human embryos for stem cell research in these countries. Whereas countries such as Australia, Belgium, China, India, Israel, Japan, Singapore, South Korea, Sweden, and the United Kingdom allow the use of human embryos and somatic cell nuclear transfer. In 2001, President George W. Bush signed an executive order that restricted federal funding for research on embryonic stem cells. This policy limited the use of federal funds for research on embryonic stem cell lines created after August 9, 2001, which significantly constrained the scope of research in this field. The restrictions were based on ethical concerns surrounding the destruction of human embryos for research purposes. And then in 2009, President Barack Obama took steps to overturn President Bush's policy on embryonic stem cell research. President Obama issued an executive order that lifted the restrictions on federal funding for research on embryonic stem cells. This decision was based on the belief that embryonic stem cell research held great promise for advancing scientific knowledge, understanding disease mechanisms, and developing potential treatments for a wide range of medical conditions. Then President Obama's action was met with support from the scientific community, patient advocacy groups, and researchers who saw the lifting of restrictions as a positive step towards advancing stem cell research and unlocking the therapeutic potential of stem cells. In the Philippines, Administrative Order No. 2013-20012 issued by DOH prohibits and restricts activities involving stem cells from embryonic aborted fetal and genetically altered animal and plant stem cells. This includes the creation, importation, promotion, marketing, and use of stem cell therapies. That's all. Thank you.